All right, guys, this is Momentum. It's Mrs. Roderick. My Honor Science Foundations class, get out your page 40 in your notes, and this will go right along. We're talking about momentum. Make sure you have your binder, some paper, pencil, calculator, and turn up your volume. Hopefully I'm loud enough. You'll have to let me know. Before we get too much into momentum, I want to first review over Newton's third law. We already talked about first law, second law. First law is law of inertia. Second law is F equals ma. And third law is for every action force, there's an equal and opposite reaction force. Where you can see there when one object exerts a force called an action force on another, the second object exerts an equal and opposite force, reaction force on the first. They may or may not produce motion. We talked a little bit about that, and with our lab that we did yesterday with the balloon, you saw that as the air went out in one direction, you know, for us with our lab, the balloon went the other direction, although of course we were horizontal. All right, so I gave you a couple examples also in class yesterday about pushing against a wall or hitting your desk, and also with swimming. When you swim, you push back on the water. If you can imagine a swimmer is pushing back with their arms, and they then move forward. So the force on the water is backwards, but then their body goes forward. Again, just examples of Newton's third law. And only when equal and opposite forces act on the same object do they result in a net force of zero. In the case of the swimmer, the action force is actually on the water, like I showed in my terrible little picture, but that's when you get the movement. All right, so momentum. I had a picture of a football player on the front because good football players have a lot of momentum. You want to be big and fast, and those are the two things that determine how much momentum you have. It's actually the product of an object's mass and its velocity. The greater the object's momentum, the harder it is to stop. You know, a big, fast football player is a lot harder to stop than a little kid going slow. Momentum for objects at rest is always zero, because if velocity equals zero, your momentum equals zero. Now I know, here's one really weird thing. Here's your formula. Okay, momentum equals mass times velocity. We use the letter P for momentum, just remember it. Since we already have M for mass, they use P for momentum. So P equals M times V. Momentum equals mass times velocity. Now the next kind of weird thing are going to be your units. Your units are, for momentum, kilograms times meters per second. You might be saying, hey, is that a Newton? No, it is not a Newton. A Newton is only equal to a kilogram times a meter per second squared, or a meter per second per second. So this is different. Now, the other weird thing is with momentum, it doesn't necessarily have to be kilograms times meters per second. It can truly be any mass unit times any velocity unit. So you can have your momentum, you could talk about it in grams, miles per hour. And I know that kind of sounds weird, but that's all it is. But kind of your standard SI units are right here. Momentum, kilograms times meters per second, mass, kilograms, velocity in meters per second. But like I said, they could actually be in anything, and you don't have to convert unless you need it to cancel out a unit there, and we'll take a look at that. All right, so a couple of sample problems. This first one, a bowling ball with a mass of 70.0 kilograms, so that's your mass, is thrown down the lane at a speed of 5.0 meters per second. What would its momentum be? So like always, we're going to list our knowns and unknowns. Momentum is our question mark because it said, what would its momentum be? Mass is 7.0 kilograms and speed is 5.0 meters per second. Okay, next thing we're going to do is write our formula. Momentum equals mass times velocity. Next, we're just going to substitute in our numbers and our units. Our mass is the 7.0 kilograms. I like to put parentheses just because with the numbers and units it gets a little jumbled, but do what you like. And then we're just going to multiply those. 7 times 5, hopefully you don't have to bust out the calculator, to get 35. 2 sig figs, 2 sig figs, 2 sig figs. And again, it's just kilograms, meters per second. You can put a dot, you can put a dash, you can put nothing if you want. It's all the same. So whatever you like. All right, so hopefully that makes sense to you. I'd like you to do this one on your own after the video. So When you're done with this, come back to this one and do it on a separate sheet of paper if it's not in your notes. And do this one on your paper as well. So I should have told you to get out a piece of paper before we got here. Sorry. All right, the next example. And again, feel free to pause this at any time to write things and rewind and whatnot. So this next one, how fast will a 20.0 kilogram object, so I'm just going to list that. That's my mass. I know because I've memorized my units. 20.0 kilograms is my mass. How fast will it be going if it has a momentum of 345 kilograms meters per second? So how fast they want us to calculate velocity. Now let's take a second. I didn't go through the algebra of this. I know you guys all aced algebra already, but just to go through it, if P equals M times V, if P equals M times V, if I want to isolate my M, I want to solve for M. To get rid of my V, I divide it. Since it's multiplied, you do the opposite mathematical operation. That'll cancel out your V. Anything you do to one side of the equal sign, you have to do to the other. So your mass would be your momentum divided by your velocity. All right. And if P equals M times V, and I want to solve for my velocity, again, since mass is multiplied by velocity, divide it to get rid of it and cancel it out. Anything you do to one side, you have to do to the other, so divide by your m. So velocity is momentum divided by mass, okay? Just be really, really careful. Remember, momentum is p, not to be confused. All right, so there's your formulas. I know you could have got those on your own, but I like to show you. All right, so we just said that the formula for V is momentum divided by mass. So we'll just substitute in those numbers and their units. 345 kilograms times meters per second divided by 20.0 kilograms. I'm going to get out my calculator because I didn't do this yet either. So 345 divided by 220.0 equals, and my calculator says 17.25. Going back to my sig figs, I have 3 sig figs here, 3 here, so 1, 2, 3. Look at that next digit. Since it's 5 or higher, my 2 becomes a 3, so 17.3. Look at your units. Kilograms on top, cancel kilograms on bottom, so I'm left with meters per second. Does that make sense for velocity? Yeah, it makes sense for velocity. So now I want you to do this one and this one also. Actually, you know what? We will do this one. I'll go ahead and do this one. This one says what mass object will move at 23.8 meters per second. That's my velocity. If it has a momentum of 754 kilograms meters per second. All right. So our velocity formula, we said velocity is momentum divided by mass. So we're just going to substitute on our numbers and our units. 754 kilograms meters per second divided by 23.8 meters per second. 754 divided by 23.8. And we get 31.6806, yada, yada, yada. 3 sig figs would be 31.7 meters per second. Cancel meters per second. We're left with kilograms. Do kilograms make sense for mass? Yes. Wish you were here to shout that out. So we're good. So you've seen a couple. We did a lot of converting with that last worksheet, 57. You can kind of go back and look at that for converting. And we'll come back to these. So now I want you to just go from weight to newtons. So you have the mass, all right? So first you're going to have to do, or yeah, you have your mass. So use your mass is weight divided by gravity formula here to figure this one out. So bring that to class tomorrow as well. Hope you like this, and let me know. Hopefully you didn't have any technical difficulties. All right, bye guys.